city designs are super complex objects, and one can talk about cities in terms of its livability, in terms of its community, a place where that is impacting climate change. At the same time, we talk about Masdar City in terms of a business center, clean tech hub, innovation hub, smart centers, all these different things, they all make up what cities are about. And so various colleagues earlier today have spoken to many of those points, but today's presentation, or this particular presentation, is really about one of those dimensions of city, which is about our role in climate mitigation and decarbonization. But what I want to do today is kind of go into a deep dive, right, in some of the details, and also talk a little bit more about the way we work and some of our experience in that we came across about the way we work before I go into a bit more our actual proposed roadmap to net zero by 2050, and areas where we have succeeded, areas where we are on our way, and areas that we know for sure there are challenges to come. So straight into the numbers. So this is our actual operational performance figures from 2022. 2023 figures are under preparation. These numbers are available in our ESG report, available on our website for downloading. And so we run a transparent information sharing. And so here you see what we're doing with energy, water, and waste mainly. But the thing I like to kind of highlight on this is the number that's related to energy. 7,416 tons is where we have made the most saving. The reverse of that is that it's also where the largest footprint is. And because it's the largest footprint, we can make the most savings. I'm not saying here that water and waste reduction is not important. All I'm saying here is these are the actual measured numbers from Masdar City in these various dimensions. What does that energy reduction mean so far? So based on our current portfolio, which is running at approaching 500,000 square meters of development, we're effectively having the equivalent of taking 1,600 large UAE type SUV type cars off the road. Just to give you a perspective of what that number actually means. However, at the same time, we have a lot of buildings under construction. In fact, we have just finished one net zero energy building, and there's another 12 buildings of high performance under construction, 2 of which are also net zero, which I will show in a moment. And we are in this kind of acceleration stage of development, whereas before we were building one building at a time, and then we became one project of multiple buildings, and now we're building multiple projects with multiple buildings at the same time. We are really scaling up. And with the current construction, as we're scaling up, you can see that by 2025, our projection is an improved energy reduction and a huge leap in terms of emissions in the carbon related to that expanded portfolio. The 38 to 47% is a significant number. It doesn't sound like a big number, but the 47% represent our entire portfolio. So you can imagine if you're just adding one net zero energy building, as strong as that building is, you are just lifting up the average of some of our older buildings. So now I'd like to touch base on a number of things that that's unique for me to thank you for being here and sharing this, because you're not going to find this on any websites. And this is about a discussion of our approach to the design. When you come to visit us at Masdar City, you see a large number of buildings. But a large number of buildings is really just the outcome of a process, and a process that we have been developing over years of how to build greener. These are some of the design parameters that we put into our projects in terms of energy, water, waste, and embodied carbon. What's important is not what the actual numbers are. What is important is that you have numbers in the first place, right? And oftentimes people say, I want to design a greener building. And they design something and they build it, but because it's such a complex subject, they really don't know if it's a greener building or not. And oftentimes you find they improve one thing and then something else drops through. So you really, really have to monitor to understand the cross-relational impact of these various going on. So the numbers is a discipline for us just to think about these things rather than the actual numbers themselves. Multidisciplinary design. And so on the screen here, we have various disciplines that, depending on the nature of a building project, they are contributing to the design of a building. It's quite a long list. And all these lists, behind this list are professional people, professional bodies, people who study different things at universities to get to where they are today. And they all somehow need to come together to design this building. And so if I had to ask, open up to the audience, which of these disciplines is the most important in the design of a building, excluding the last one here, because I'm the owner representative. I mean, do I have any offers? What do you think? Which one is most important? I mean, they all have to be there to contribute to the building, but which one is most important?
Scheduling and planning. To start with.
Any more offers? No? No? Well, the answer to me is a very simple answer. Sorry? Someone said all of them. You're right, they're all important. That's why they're on the screen, because they will have to contribute to them. But which one is most important? All of them means they're all the same. So the most important one, right, is very simple. It's my one. That's the answer for all of you, because you all believe that your subject is the most important one. It's the one you selected to dedicate your life to, unless it was chosen for you by your parents, which happens in real life sometimes. But in most cases, you choose a subject for you and you dedicate your life to it, and you're passionate about it. And then suddenly you're in a room with 15 other people who are also very passionate about their subject. And there you have the start of chaos. We're trying to design a building. And so in order to make a building go green, which actually relies on collaborative and integrated design, you have to figure out how do you get all these people to run in the same direction under a common mission statement. So that is a kind of a process challenge that we have to go through. This is a picture of the part of the facade from the Siemens building at Masdar City, right? And traditionally, when you design a facade, you go to a facade designer, give me some options for some nice facades. They produce option 1, 2, 3, 4. The owner chooses one, right? And then off you go, because it looks nice, right? But within this facade design, actually the facade design impact all these other disciplines around there. Or to reverse that, all the other disciplines impact facade design, right? The lighting design that you do obviously would change depending on how large your windows are. How large windows are is dependent on will determine how much heat you let in, which will impact the air conditioning system, right? The engineering, Right? Even the shape of the room behind it, even the colors of the walls behind it actually has an impact. But do these people normally talk to each other when they are designing this? No, they don't. And that's what we found as a practical reality. Yes, they share drawings. Yes, they call up on a computer. Yes, they overlay them. Yes, we have clash detection softwares and this kind of thing. But oftentimes they don't talk to each other. So this is in the building industry, and I'm sure this happens in other industry as well. So how do you make these people talk to each other in the right way? Well, there was no simple answer to that, but over the years we have been trying out different things. For example, we had one actual real situation at Masdar City where the architects designed their building, presented it us, explained all about it, and someone in the audience picked up, why is this building so tall? Why is the ceiling space above the floor, the ceiling void, so large? Which was about, in this particular case, a building 5 stories, 1.2 meter ceiling space. And it is quite large. The architect showed a drawing cut through the building. He said, is this large because the ceiling is full of air ducts? See, used up. You cannot move the ceiling up anymore. But it was a long, thin building. So I asked, what's happening at the other end of the building? Cut it through. The ceiling was just empty because the ducts were coming at one end, and by the time it gets to the other end, the ducts run out. But ceiling has to be flat, right? And it's low, and it's determined by the critical point where all the ducts coming out. And so, turned to the air conditioning engineer. Said, "You size this?" I said, "Yes." So, what do you think? He said, "It works." Right? I said, "I know it works, but what do you think?" Yeah, we've got a lot of empty space in there. Then through this discussion, we weren't getting anywhere. Then we had an idea. We said, well, actually, I said, much to the protest of the architect, said, Mr. Mechanical Engineer, Mr. Air Condition Engineer, we are going to change roles that you're going to undertake. You will now be the architect for the next 2 weeks. The architect protested. We said, you had your chance just for 2 weeks. Let the engineer be the architect. So the air conditioner engineer said, me, architect? You mean I can actually move rooms around? I said, well, you're an architect. You can move it all around. Do that. But from an engineering point of view, where would you put your air conditioning rooms? He came back 2 weeks later within the same footprint, and the rooms are all rearranged. Very simple. You put the plant in the middle, so it comes up. It goes out. And because you did that, the 1.2 meter ceiling void became 700. It was a half a meter saving per floor across 5 or 6 stories, actually. That's a 3 meter saving, and that entire building came down by 3 meters. That's the whole floor. Right? As an owner representative, I was extremely happy because we were saving 3 meters of facade all the way around. It was a smaller volume, which actually ended up with less air conditioning. The chilled air had less distance to travel because it was coming through the middle. So efficiency was improved and. So it was saving all the way through. So who says sustainability costs money? Done in the right way, it actually can save you money, but it depends on what you are looking for. In our Masdar City, in our design process, we're trying to find and optimize all these different type of opportunities. And when you do that, that would explain this diagram. And this is just a diagram, which is represented by a blue zone. Let's call this Abu Dhabi average cost of construction. And summarizing some of the studies that was done at various stages of green building rating system, cheapest and most expensive. You see that most expensive become even more expensive, but at the cheapness level, low cost level stays very close to the average. That's because it's extremely difficult survey to do. Right? Because when you have, let's say, a high-end green-rated building, a LEED, let's say platinum, which is the highest rating, and then you find out how much it costs, you're really not sure is if the cost is due to more insulation, or you happen to specify the Italian marble for all the toilets. You just don't know because the survey doesn't go into that level of depth. And you'll never be able to compare apple to apple anyway. So it's a kind of pointless exercise. But the message is clear. What Masdar City is interested in is what happens here, right? And what we found is people who are reaching this point here is working a similar lines to what I was describing before. Finding those things the way you have a win-win situation in being environmentally efficient, energy efficient, and at the same time addressing the cost issue. Because I have to say here that Masdar City is a wholly owned subsidiary of the Mubadala investment company. It's an investment company. So we are also an investment company. It means that all the projects we do is driven by investment. It means that complementing the environmental targets that we have specific targets for IRR. We have specific targets for ROIs, right? And we look at payback periods. I know it might sound odd me being an architect talking about payback periods, but that's what we have to do to turn this into reality. We work in an organization, and I mentioned collaboration, where architects need to understand cost and finance, and cost and finance on the reverse side needs to understand something about architecture. And I think that is one of the big advances that we've made over the years at Masdar City, with this cross culture, cross discipline, where we start off arguing with each other, and after years of exhaustive arguing, we occasionally like each other, right? Because out of that, great solutions are born. No, we actually like each other a lot, actually. And so this diagram, which was represented earlier today by my colleagues, is a summary to do this. The environment has to be approached in a certain way. For us, if anyone's here in my previous session, was talking about maxing out concepts borrowed from traditional design, from passive design, from understanding shapes of buildings, openings and everything, before you actually increase your investment for active management and finally to power generation. And when you put all this together, you get certain performance criteria of energy efficiency just based on the passive and active approach before you put on any PV panels, right? So these numbers move up and down a bit, and there's no apologies for that. This is what happens in real life. Buildings get used a different way. Building users, some are more environmentally conscious than others, etc. People forget to close doors, and things get broken. But we are doing our best to kind of optimize the passive design. And we've found that we can achieve up to 50% energy saving just by taking this approach. Now, in the triangle before, I said we also, after you exhaust this, you add the renewable energy. And so when you add the renewable energy to this, right, you can see it's a very different series of numbers come out. That starts from 0 and ends up at 114 at the bottom. 0 for the 2012 incubator building is because being an investment company, renewable energy on our buildings was simply unaffordable at the time. We were talking about 40 cents per kilowatt hour at that particular time. Fast forward into 2023, 2024, 2025, when at scale solar farm are delivering at less than 2 cents per kilowatt hour, down from 40 cents. Suddenly become a viable proposition to introduce PVs. So there's been a gradual increase over the years. And when it gets to the bottom 3 buildings, where you're hitting over 100, right? And combining now the previous passive number with the PV numbers, so you understand why that's still only 45, and it moves up to over 100. And effectively, those three buildings at the bottom are defined as net zero energy buildings under operation. This building, this is just a rendering, but we recently completed it. It's a net zero energy building. We call it what does it look like? It looks like a shoebox, right? And we do call it a shoebox. It's as simple as a shoebox because we understand that not every building is meant to be iconic. In fact, that a large majority, 90% plus of buildings, is your everyday buildings. Most buildings are just shoeboxes. So we thought we'd design a shoebox, but it just happened to be a net zero energy shoebox, right? We gave this a tagline, net zero energy for all. And why net zero energy for all? Is to make it as affordable as we can. And remember, I mentioned earlier about trying to get everyone to run in the same direction. So we told the entire integrated design team, net zero energy for all. Every decision you make is net zero energy for all. And that got people to focus on efficiencies and to focus on the cost effectiveness. One of which is net zero energy, the bottom left-hand building. This building, we call it the CoLab building. It's a shared living and shared working building. We had this idea for this, that half the building is for co-living, half the building is for co-working. And the idea behind this is that any mechanical system you have, we're working very hard on the office side during the day. And during the night, when people are not, or less people are working, we're working very hard on the residential side. So there's a kind of efficiency in that. And on top of that, we made it net zero energy in operation at the same time. And this one is slated for completion by the end of next year. It's under construction at the moment. Another project that is under construction, we call this the MC Square, 7 office buildings, of which this one here is also on target for net zero energies, following the same principles I described earlier. What's also interesting about this project is that it's next to an existing building here, the IRENA, International Renewable Energy Agency. They're headquartered in there, and they share the building with the Emirates Nuclear Energy Corporation. And at COP28, we announced the tenant coming into this net zero energy building. It's the Abu Dhabi Department of Energy, which is quite interesting, a Department of Energy in a zero energy building. And so we have 3 entities related to energy, all within 1 minute walk from each other, right? Which, to me personally, I see as our contribution to the energy transition conversation. Total encouragement. There's some details, the walkability of the place, which is a standard feature where we can optimize it throughout of Masdar City. A close-up of the headquarter building. We had to really max out how much PV we can put in there. And so that's why the PV comes down and forms the port cochere for the whole building. There's no PV on the right because on the right-hand side, it's actually shaded by the IRENA building. So this is a kind of a shroud building with a part cut off that's actually shaded. It's a very simple concept. And this is a picture of the atrium taken about 3 months ago under construction. And so now transposing the way we work into a proposed way forward to net zero. Right. Currently, the EUI energy use intensity, or the amount of energy you use per square meter of building, we're running around 145 kilowatt hour per square meter of building. Right? That's operational. We need to get that down to 100 somehow. right, in order to give us fighting chance to get to this place here. When the new projects are completed by 2025, that average is going to move down to 131. So it's going in the right direction. But you do have the challenge of the law of diminishing returns. So the more you push, the harder it gets. But that's what we do. That's our day job, to keep improving and improving and improving. And if we can do that, we can actually get to scope 1 and 2 net zero simply by adding 10 megawatt. Now, 10 megawatt is not, it's a lot for a city, but it's not too much. But we can only do that because of the foundation of passive design to reduce our footprint in the first place. And in addition, we have 10 megawatt running at Masdar City already. So by then we have 20 megawatts within our field. The PVs on the roof you saw in the design, and we got some PVs on some of ours on our roads as well, is already contributing to over 2 megawatts between now and 2030. So we are on our way to adding to that 10 megawatts. We also know what we are going to be building between 2030 and 2040, because it is a defined city, so we know exactly how much there is left to build in that period. And that equates, using the same design philosophy, another 15 megawatts. And by that time, 2040, if we followed an engineered world, we'll be net zero in operation. However, we don't live in an engineered world. And so we already have many examples where buildings are used differently to how they're designed. Right? During the design, you assume how many hours you're going to be working in the office. You assume how many times per week you're going to turn on the washing machine. Right? And we all know what assumption does. So it's important to actually measure. So allowed us a piece of time to measure, understand, fine-tune, add, subtract accordingly to actually get to 2050. 2050 is not something that's going to happen on December the 31st in 2049. Right? It has to be a gradual. And I think that's, to me, is one of the important things about Masdar City, is this continuing learning, understanding what works and doesn't work. So, net zero to 2050, very, very simple, or not quite. Anyone knows what's missing here? Embodied carbon. Do we know what embodied carbon is? Embodied carbon is the emissions from the construction, right? And on a broader terms, actually the emission from the maintenance of the buildings and any replacement we make, and also to its full life cycle, also emission from demolition. But we're concentrating on the first part, on the upfront embodied carbon from the construction aspect. The challenge with embodied carbon is that there is very, very limited data in the entire world. Right? When people say we want to reduce it by X percentage, the next question is X percentage from what? Right? Because there is no recognized baseline. However, there are a number of studies and journals out there that seem to converge on this particular number of what is business as usual. Right? And so we're using this for the time being. Right? Some people are suggesting that Masdar City can be the baseline, which I think is going to be a tough call because we're using a lot of green materials already. And if you use that as a baseline, it means that your business as usual building becomes negative. So 800 is a good starting point, I believe. And our portfolio across all our buildings at the end of 2022 is averaging on 642. Now that's an average because we actually have some buildings over 1,000, early buildings. And we have buildings that are around 500. The 1,000 building is actually a steel structure building. The steel has a very, very high carbon footprint. At least it had when we were building it back in 2012. And this was the first building, the incubator building you saw there. Right? And so it's not surprising to say that after that venture, it's our only total steel structure building because of impact on the carbon. Maybe that's changed in the future. We are engaged in a number of companies who's doing a lot in decarbonizing steel as well. This is where we think MC Square HQ is heading for. This is the Shroud building, right, where the Department of Energy will be residing. I think we'll end up being pretty close to this because the contractor is using majority of materials that we are specifying already. The shoebox is lower than the MC Square. For one very simple reason, because the shoebox has surface parking, whereas the MC Square HQ has basement parking, and you're carrying all this concrete underground. So one has to be careful when one starts going downwards from a embodied carbon point of view. Right? And then we are trying to get to 50% reduction by 2030, which in our case here is 400. I think to share some ideas, our latest design, we're targeting somewhere between 450 and 500. Again, the law of diminishing return tells you it gets harder and harder as you go on. But I think whereas we have control of the operational energy and water, it's very difficult to have control of the embodied carbon because you are reliant on other industries. This is talking about the steel industry, the insulation industry, the concrete industry, right? And so we're not going to get there unless all these different things converge, right? But this is, at the end of the day, still work in progress. And if you come back next year, I hope to show you a lower number because this is my last slide. And thank you. Open to questions.
Thank you.
Okay, you have the first question.
You have a lot of solar energy. I didn't see any geothermal. Have you? What was the reason not to consider the geothermal energy?
In 2008, 2009, around there, we worked with a company from Iceland, and we were wondering if we had geothermal energy at Masdar City. So a drilling rig was brought to Masdar City, and we drilled down 2.5 kilometers. Fortunately, we did not hit oil, and because if we did, then I think Masdar City would change its business strategy there and then, right? But we went down 2.5 kilometers, and we found water that was, I think from memory, about 120 or 125 degrees Celsius. So it's higher than boiling water because the water's under pressure, so the temperature goes up. Unfortunately, according to engineers, that temperature is not high enough to make it commercially viable at the time. So the well was abandoned. Fast forward to last year, that well is being reused now, and it's being reused by Tabreed. They're not going down that deep, but they are tapping in a certain level of geothermal energy, and they're introducing that into a district cooling plant, which is serving Masdar City. So the district cooling plant that's serving Masdar City has energy that is a 10% contribution from geothermal into that mix. That's all we've done so far on geothermal.
Who has the next question? No? Oh, there is.
And how do you calculate the scope 3 emission?
Scope 3 emissions, which is essentially define that any emission caused by you that's not scope 1 and 2, right? So backtrack. Just to make sure everyone understands, scope 1 emission is CO2 emitted from the site, like if you burn a diesel engine, right? Scope 2 is purchased energy, which is usually purchased electricity or purchased cooling, etc. Scope 3 is everything else, from business travel to purchasing goods and materials to, in our case, construction, right? So scope 3 for those who've been in this area, has 16 categories. That's make it really, really complex. It's really, really broken down. Give you an example. Business travel is one category of scope 3. Right? Investments is another category. Buying stationery fits in another category. But I think you're talking about scope 3 as it relates to embodied carbon. And in that area, the way that we are measuring it is that there are certain databases that exist in this world that talks about what's your embodied carbon, also carbon emission for different materials, be it concrete or steel or insulation or glass. And what we simply do, we take these data and we also collect the volume of materials that we do from the bill of quantities. And if you multiply that through, you get a number coming out. Now, these numbers are evolving all the time because the supply chain is changing on an annual basis. So you have to use the latest data. Our numbers and our carbon footprint is probably high compared to today's construction because some of that data is based on stuff that was built more than 10 years ago when embodied carbon was much higher. Right? But the simple response is that there's a lot of data out there. You just need to get at it. It's available. GHG protocol websites give you all the links to databases that you can use. Or there's some amazing softwares out there that simplifies this process.